Today we will see LeetCode problem number 1035, and it says that you are given two array of integers and you have to join different pairs of integers between these two lists. So we have A and B, and you have to make the connections such that only equal numbers can be connected. So 5 can be connected to 5, 2 can be connected to 2, and again 5, or there are other possibilities also like 5, 1, 2, and the condition is that none of these lines should intersect each other. For example, now if I have drawn here 3 connections, but if I try to draw a fourth connection like 1 and 1, these are also equal, so I can connect them, but you see that this line intersects with that, so that is not allowed. So what is the maximum number of connections you can make such that none of these lines intersect each other? So for this example, the solution is 3. Although there is no unique solution here, there can be multiple solutions. For example, you can connect this 2 and 2, then this 1 and 1, then this 2 and 2, and still it will work. Or instead of connecting 2 and 2, you can connect 5 and 5. Similarly, you can get rid of this 2 connection and add 1 1 here. So multiple solutions are there, but none of them is more than 3 without crossing each other. So how can we find it? And here we will use a dynamic programming approach. And if you have already worked on some of the dynamic programming problems like longest common subsequence, then this I felt to be exact replica of that longest common subsequence problem. In that you were given two strings. Strings have characters in them, and you have to find the longest subsequence which is common to both. So if you look at A and B and think of these digits as characters, so characters are nothing but kind of a integer because each character has one ASCII value associated with them. So here also you see that we have a subsequence and not substring. And what is the meaning of subsequence? You can skip some of the characters in between. So here 5 to 5 is a subsequence of A, and the same thing is in B, since the connections are always between same numbers. So same subsequence is present in B also. So you can think of them as 5 to 5 is a subsequence of A as well as B. And here also you cannot change the order, since if you connect a line from this side to this side, the next digit should be connected to a number which is next in the list. If it's before this number, then it will cross. So that's also satisfied. So only equal characters are connected and the sequence is also maintained. So it satisfies both the properties of longest common subsequence, that is, it should be subsequence here as well as here, and it should be same in both of these. That's why common. So you can think of this as a longest common subsequence problem. There is no difference here. So let's see how we can approach it. So we can break the problem like this is A, this is B, and let's say it has M, its size is M and its size is N. So what can be scenarios? The last number can be same or different. If these are same, so we are trying to find TMN, that is on all the entire length of A and B. So if AM is equal to BN, that is their last numbers are same, then safely we can add them. This will not hinder any of the other solutions that exist before them, since it cannot intersect with anyone. Both are connecting the rightmost numbers, so there is no possibility of this line intersecting with anybody else. So if this is the case, then we will definitely take this line. This line will always be part of the solution. So what we will do, we have joined them, so we have one less element on both the arrays A and B. So what we will do, 1 plus this is 1, so 1 is added, since we have one element less in each of these, so we will be solving a smaller problem, and 1 is added since this connection is guaranteed if it's equal. Else these are unequal, then either there is a line from one of these. There cannot be this line for sure since these are not equal, but there can be line from this last character of A to some other number in B, or there can be a line from this last number of B to some other number in A, but not both. Why? Let's say this is the last, there are more numbers on this side, and similarly here we are looking at the last digits of A and B, and these are not equal. For equal, we have already seen that we will for sure take this line and remove both of these. If they are not equal, then this line cannot exist for sure, because we are not allowed to connect unequal numbers. And now there cannot be a line from this to some other number. It has to be to some number before this, and also from this to some other number, since they will cross, because this line cannot go to this, so it will go to some number before this, and this line will also go to some number before this. So in that way they will cross each other. So both of these cannot be present. One can be present or may not be present. So if they are not equal, then we will take max of t m minus 1 n and t m n minus 1. So at least one of the numbers is not part of the solution, either this or this. Both of them may not be part of the solution as well. So in first case we remove this one and take the result of this part with the complete B, and in the second case we remove the last number of B and take the result with complete A and take the maximum of that. So this is the recursive approach, but again here we cannot do it recursively, since mn depends on m minus 1 n m n minus 1 and m minus 1 n minus 1. These are the three things we require for tmn. In case of equality we need this one. In case of inequality we need these two. All three are smaller than this, and if you expand this, it will again break into m minus 1 n minus 1, m minus 1 n minus 2, and one more m n minus 2. And here also this is m minus 1 n minus 1, and it will further expand. So you see that this, how rapidly this tree is expanding. At first level, at root level it's 1 node, next level it's 3 node, at next level it's 3 times 3, that is 3 square or 27. At next it would be 3 cube or 81. So even at third level it has reached 81. So it will be 3 raised to the power h, where h is the height or the level. So it's exponential, and it will quickly stop working for a fair size of arrays. And so that is the first thing we need to take care, how we can avoid this. And we are solving some problems again and again. For example, here m minus 1 n minus 1 is there, and here also we got m minus 1 n minus 1, and this will further be expanded. So all of those solutions which we have solved here, we will again be solving it. So it's kind of recomputation. So how can we avoid that? So that's where dynamic programming comes into picture. Both properties are satisfied here. Overlapping subproblems, you can see that there is a high overlap. This is solved, we are solving it again, and all of these will be solved here also if you expand this. So overlapping subproblems is the first property, and optimal substructure, that is if I solve if I find the optimal solution of smaller subproblems, then by solving them we get the optimal solution of the larger problem. So here mn is broken down into the solution of Mn depends on m minus 1 n minus 1, m minus 1 n, and m n minus 1. All of them are smaller. So optimal substructure property is also satisfied. So we will use dynamic programming approach here. So let's build the table for this, just like longest common subsequence case. So on this vertical axis, I write the numbers of A, and horizontal axis, I write the numbers of B. And this I have added one extra row and one extra column. And here a position ij denotes, this is I, this is j, that you take this B from beginning till j, not till end. So what will this denote? This will denote this is 5, this is 5 comma 6. So this denotes that from A you take 0 to 4, and in B you take 0 to 5. So you take the entire A and entire B. So that will be put here. Here it means that you take none of A, none of B. So it will be 0. And this row denotes that we have not, A is empty. So if A is empty, the size will be 0. Similarly, this column denotes that B is empty. Again, it will be 0. This column denotes that take the first element. So this is 1 1 position. That means take one element of A from beginning and one element of B from beginning. So we will take 2 and 10. So if we have 2 and 10, how many such lines I can draw? 0, because these are not equal. And let's take help of this recursion here, that if these are same, then we need 1 plus m minus 1 n minus 1. So let me write it here again. If these are same, then Tm n equal to 1 plus T m minus 1 n minus 1, or better write it in dp to denote dynamic programming. And if they are not equal, then this same thing will be max of dp m minus 1 n and dp m n minus 1. So if this is mn row, what is this m minus 1 n minus 1? It will be diagonally up. So if we are looking here, if they are same, we look diagonally up here, this cell. If they are unequal, we look at this and this and take the max of these two. So here 2 and 10 are not equal, so we take the maximum of this and this, top and left. It's 0, so it's 0. Here 2 is not equal to 5, so again max of these two, which is 0. Now this is equal case, 2 is equal to 2. So what we will do, 1 plus this value diagonally up. So here it's 0, so it will become 1. And if you see it logically, we have taken 10, 5, 2, 3 numbers from this B, and just one value from A. So this was, between this and this it was 0, between this and this also it was 0, but when we added 2, we can draw one line. So the solution of this thing is 1, and that's reflected here. Again not equal, so max of these two, 1, not equal, 1, then it's equal, so this diagonal plus 1, so it's 1. So with one number in one of the list, you cannot make more than 1. So once you get a 1 here, it will be at least larger for numbers greater than this, since you are adding more numbers to it in the end. So this will not reduce your result. Again here not equal, so 0, then it's equal, so 1 plus this, not equal, so max of these two, not equal, 1, equal, so 1 plus this, 2. Now let's see why it's 2. Here we have taken 2 and 5, and here we have taken 10, 5, 2, 1, 5. So this we can draw and this we can draw. So 2 is there and correctly being captured here, and here not equal, so max of these two not equal 0 0, sorry, one of maximum of this and this, so it will be 1, not equal, so 1, equal, so 1 plus 1 2, not equal 2, not equal 2, then not equal 0 1, this is equal, so 1 plus 1 2, then not equal, not equal, and equal, so 3, then 0, and this is equal, not equal, not equal, equal, not equal, and this is the final result where we take the complete A and complete B, so we return 3, and this is the solution. So let's write the code for this. So first we will write it in C++, then Java and Python. So we will create one 2D array, and the array will be initialized with 0 values initially. So int m equal to a dot size int n equal to so we want m rows and n columns and plus 1, so m plus 1, and each row is a vector of n plus 1 columns. Initialized to 0. And let's start from 1. Since this 0 row and column are dummy, we will just use them, that's why we populated them. So what should be dpij if a of I minus 1. So here we are starting from 1 1 instead of 0 0, and we have taken one extra size, but in A the number will start from 0 till m minus 1. So if this is equal to b of j minus 1, then it's 1 plus dp I minus 1 j minus 1, else max of dp I j minus 1 and dp I minus 1 and j. That's it. This will populate this dp array, and finally we will return the last cell. So let's see if it works or not. So it works for this case. Let's try the second one. So here it should return 3. And this works as expected. So let's submit. and the solution is accepted. Now we will write the same thing in Java, and we will not require any major change here. And everything else should remain same. So let's see. And this works, so let's submit. And the solution is accepted in Java as well. So all test cases pass within 4 milliseconds, and we are around the top of the chart. And finally, let's do it in Python. So we will create a vector of zeros. So this creates n+1 vectors of zeros. So these denotes the different, this denotes one row of DP. We need m+1 such rows. So what we will do, for m+1. So this will create m+1 such rows, all with zeros, and for I in range m+1 starting from 1, and for j in range 1 2, and that's it. Let's see. And it works as expected. So let's submit. And the solution is accepted in Python as well.